Your textbook lied about how planes fly. The real answer is Newton. Every kid learns the same explanation. Air goes faster over a curved wing top. Bernoulli says pressure drops, the plane lifts. There's just one problem. Stunt planes fly upside down. Paper airplanes have flat wings. Both work fine. The textbook isn't completely wrong. But the real reason planes fly is much simpler, and Isaac Newton figured it out 300 years. The textbook story goes like this. A wing is curved on top, flat on the bottom. Air molecules splitting around the wing have to meet up again at the trailing edge at the same time. The top path is longer, so the top air must travel faster. Bernoulli's principle says faster moving air has lower pressure. Higher pressure below, lower pressure above, and the wing gets pushed upward. This is called the equal transit time theory, and it's been in physics textbooks for almost a century. It has two fatal problems. First, there's no law of physics that says the air has to meet back up at the same time. It doesn't. High-speed cameras of wings in wind tunnels show the top air actually arrives at the trailing edge well before the bottom air. The split molecules never reunite. Second, if curvature were the whole story, an upside-down plane couldn't fly. The curved surface would now be on the bottom, producing downward lift. But stunt planes fly inverted every single day. Something else has to be doing most of the work. Here's what's really happening. A wing isn't flat. It's tilted slightly upward at the front by an angle pilots call the angle of attack. As the plane moves forward, that tilted surface acts like a giant scoop. Air slams into the bottom of the wing and gets deflected downward. At the same time, the curved top surface pulls air down behind the wing in what aerodynamicists call downwash. Both surfaces are doing the same job, pushing a large amount of air downward. Now Newton's third law kicks in. For every action, there is an equal and opposite reaction. The wing pushes air down. The air pushes the wing up. That upward push is lift. This is why a flat paper airplane with no curve at all still flies. It's why a stunt plane works upside down. Pilots just increase the angle of attack in the other direction, and the wing keeps deflecting air downward. Bernoulli isn't wrong. The pressure difference is real and contributes maybe 20 to 30% of total lift. But the majority, the part that actually keeps a 75,000 kilogram airliner in the sky, is pure momentum transfer. We can prove this with one number. A Boeing 747 at cruise weighs about 300,000 kilograms. To stay in the air, its wings must generate 300,000 kilograms of upward force every single second. Where does that force come from? Engineers worked it out using Newton's second law. Force equals mass times acceleration. For a 747, the wings push roughly 1 ton of air downward every second the plane is airborne. 1 ton every second, accelerated downward by about 300 meters per second. Multiply mass by that acceleration, and you get exactly the upward force needed to hold the airplane up. The numbers match Newton's third law perfectly. They don't match Bernoulli alone. Wind tunnel measurements confirm it directly. NASA and university aerodynamics labs measure the pressure difference between the top and bottom of a wing, and they measure the mass and velocity of the downwash behind it. The downwash term dominates. It's where most of the lift comes from. So next time you board a plane, the thing keeping you in the air isn't some mysterious curve. It's Isaac Newton, and a wing the size of a tennis court shoving a swimming pool's worth of air toward the ground every few seconds. That's how planes really fly. If you want more answers your textbook got half right, mechanism first, evidence second, subscribe to Curious Science. Tomorrow, why you have a belly button and the strange scar from a cord you already forgot.